The ground beneath your feet holds secrets that most people walk past every single day. Unremarkable stones, dull fragments, rocks so ordinary, so forgettable, that they blend into the landscape like shadows at noon. But some of these ugly rocks carry a message written in the language of pressure, heat, and time, a message that screams one undeniable truth: diamonds are close. Not every stone tells this story. Not every fragment carries the fingerprints of the deep earth forces that push precious gems toward the surface. But 10 specific rock types do. 10 indicators so reliable, so geologically honest, that their presence alone can expose diamond-bearing ground before a single shovel breaks the soil. These are not beautiful stones. They are scarred, weathered, and dismissed by those who do not know what they are witnessing. But to those who understand their behavior, their texture, their impossible density, these rocks are nature's own treasure map. Each one of these 10 ugly rocks formed under conditions that only exist where diamonds are born, miles beneath the surface, in chambers of unimaginable pressure, where carbon crystallizes into the hardest substance on Earth. These rocks traveled the same violent journey upward, riding ancient volcanic eruptions carried by mineral-rich magma that forced its way through fractures in the planet's crust. And when that eruption cooled, when the violence settled into stillness, these rocks remained, scattered across the surface, marking the exact locations where diamond-bearing material broke through. Their appearance deceives, their colors are muted, earthy, forgettable. Their shapes are irregular, rough, unremarkable to the untrained eye, but their presence is never accidental. They settle only where the Earth's deepest forces have spoken, where ancient kimberlite pipes once erupted, where lamproite deposits cooled into hardened veins, where the geology itself remembers the journey of diamonds from the mantle to the surface. And now you are about to discover all 10 of them, the rocks that expose what the Earth tries to hide, the indicators that separate ordinary ground from diamond-bearing terrain, the ugly stones that hold the most valuable secrets. But before we begin, if you want to learn how to read the Earth's hidden language, hit that subscribe button and ring the notification bell. This knowledge could change the way you see every rock, every trail, every forgotten hillside. Now let's get started. Rock Mer 1, Kimberlite, the diamond carrier. The first ugly rock appears in blue, gray, and green shades, weathered into brown and yellow tones that make it look like common clay. But beneath that ordinary exterior lies the single most important rock in diamond exploration. Kimberlite carries diamonds from depths exceeding 100 miles, straight through the Earth's crust in violent volcanic eruptions. Its texture gives the first clue: kimberlite feels softer than surrounding stones. The surface often has a slick, soapy quality from minerals like serpentine and olivine. Dark fragments called xenoliths pepper its structure, chunks torn from the mantle and carried upward. Fresh kimberlite appears blue-gray or greenish, but weathering transforms it into yellowish-brown as iron oxidizes. Wherever kimberlite appears, the possibility of diamonds becomes real. Not every kimberlite pipe contains gems, but every diamond found in primary deposits comes from kimberlite or its relative lamproite. Rock number 2, Eclogite, the high-pressure companion. The second indicator carries a density that defies its size. Eclogite appears in deep red and green combinations, mottled with mineral bands. It feels impossibly heavy, denser than almost any surface rock. That density tells the story. Eclogite forms only under extreme pressure, 30 miles or more beneath the surface, in the same depth range where diamonds crystallize. When kimberlite erupts, it tears eclogite fragments from mantle walls, carrying them upward as embedded xenoliths. The red and green coloration comes from garnet and pyroxene crystals. Garnets appear as deep red nodules in a dark green pyroxene matrix. Eclogite's density ranges from 3.4 to 3.6 grams per cubic centimeter. When placed in water, it sinks immediately with disproportionate force, and eclogite never appears alone. Where these fragments scatter, kimberlite lies nearby. Rock Memca 3, Peridotite, the mantle fragment. The third rock appears in dark green and black, weathered into rusty brown surfaces. Its texture is granular with visible olivine crystals. Peridotite is a piece of the Earth's mantle itself, torn loose during kimberlite eruptions. Fresh peridotite displays vibrant olive green, but exposure quickly oxidizes the iron, creating rusty coatings. Scratching through the surface reveals the green interior and coarse olivine crystals. The presence of peridotite fragments confirms the depth and violence of the original eruption. And those same forces carried diamonds. Rock number 4, Ilmenite, the black magnetic witness. The fourth rock appears as small black grains scattered across diamond-bearing terrain. Ilmenite looks like coal, dull and unremarkable, but this iron titanium oxide carries magnetic properties that betray its deep earth origins. Ilmenite crystallizes in kimberlite magma as it rises from the mantle. When kimberlite erodes, ilmenite particles scatter downslope into streams and low areas, accumulating in black sand deposits. A strong magnet attracts these grains, lifting them in visible clusters. Diamond prospectors use ilmenite as a tracking mineral, following its distribution backward toward the source. Where concentrations increase and grains become fresher, the kimberlite pipe lies closer. Rock number 5, Pyrope Garnet, the red indicator crystal. The fifth rock appears as small rounded pebbles in deep red and purple hues. Pyrope garnet looks semi-precious but carries one of the strongest correlations with diamond deposits of any indicator mineral. Pyrope forms only under extreme mantle pressures, the same environment where diamonds crystallize. It requires depths exceeding 60 miles and temperatures above 1000 degrees Celsius. True pyrope displays blood red to purplish red, often with a slight orange tint. The chemistry reveals everything. G10 garnets contain high chromium and low calcium, a signature forming only in the diamond stability zone. These garnets in surface samples are among the most reliable indicators of diamond potential. The ugly red pebbles carry the exact chemical fingerprint of diamond formation. Rock number 6, Chrome Diopside, the green crystal marker. The sixth indicator appears as small green crystals, emerald tinted and translucent when thin. Chrome diopside looks like cheap glass beads but forms in the same deep mantle environment as diamonds. This pyroxene mineral is colored by chromium, the same element giving pyrope its red hue. The green ranges from pale lime to deep forest green. When found with pyrope garnet and ilmenite, chrome diopside confirms the complete indicator suite, dramatically increasing the probability of diamond-bearing rock beneath. Rock 7, Chromite, the black metallic cube. The seventh rock appears as tiny black cubes and metallic chunks in heavy mineral samples. Chromite looks like industrial slag but forms exclusively in ultramafic rocks from the deep mantle, the same family hosting kimberlite. Chromite's cubic crystal structure creates distinctive geometric shapes. The mineral is extremely hard with a specific gravity exceeding 4.5, making it one of the densest common minerals. High chromite concentrations in stream sediments indicate ultramafic rocks are eroding nearby, rocks potentially carrying diamonds. Rock number 8, Olivine, the green sand of deep origins. The eighth indicator appears as yellowish-green sand grains that weather quickly into rusty brown coatings. Olivine dominates the Earth's upper mantle and serves as the primary component of peridotite. Fresh olivine displays clear, glassy appearance with pale green coloration, but surface exposure oxidizes the iron rapidly. Because olivine weathers so fast, its presence in fresh, unoxidized form indicates the source rock is very close, actively eroding. Streams carrying bright green olivine grains point directly toward kimberlite outcrops currently weathering. Fresh olivine alongside pyrope, chrome diopside, and ilmenite completes the full indicator suite, confirming mantle-derived material is weathering nearby. Rock number 9, Pyro-Ilmenite, the magnesium-rich black grain. The ninth rock appears nearly identical to regular ilmenite, black and metallic with magnetic properties, but Pyro-Ilmenite carries higher magnesium content, a chemical signature forming only in kimberlite magma under specific conditions. Regular ilmenite forms in many rock types, but Pyro-Ilmenite's high magnesium restricts its formation to kimberlite and related ultramafic magmas. This makes Pyro-Ilmenite the single most reliable indicator that the source rock is true kimberlite. When stream samples contain high Pyro-Ilmenite percentages, the probability of true kimberlite increases dramatically. Rock number 10, Serpentinized Kimberlite, the weathered deceiver. The 10th rock appears as yellow-brown clay-like material, soft and crumbly. Serpentinized Kimberlite represents the final weathering stage, when original blue-gray rock has transformed completely into serpentine minerals and clay. It looks worthless, like compacted dirt. Yet beneath that disguise lies actual diamond-bearing rock. Serpentinization occurs when kimberlite's olivine and pyroxene react with water over centuries. The process softens the rock, making it crumble and blend into surrounding soils. But the transformation doesn't destroy diamonds. The crystals remain intact, locked within the serpentinized matrix. The yellow-brown color and waxy texture distinguish it from ordinary clay. It feels slicker, almost greasy when wet, often retaining faint green tints beneath oxidized surfaces. 10 ugly rocks, 10 geological messengers carrying the Earth's deepest secrets, each formed under conditions that exist only where diamonds crystallize. Each traveled the same violent path from mantle to surface, each now scattered across forgotten landscapes waiting to reveal what lies beneath. These rocks don't sparkle or shine, they simply exist, marking the places where the planet opened pathways from depths that crush carbon into perfection. And now you know their language. Now you understand what the Earth has been trying to say.